Good morning, viewers. Welcome to this lesson. With you, we will be taking you through mathematics lesson. Is Mwalimu Omondi Johnny from Parklands Baptist School. Today, we are going to learn about volume of combined solids. Volume of combined solids. When we talk about volume of combined solids, which means we have different solids put together. For example, if given a wedge combined with a cube, then we call that is volume of combined solid. Or we may have a cuboid, whereas a cylinder has been drilled in it. Then we find the volume of what is left. Now, I'll take you through some work. The first one, mathematics. Volume of combined solids. Volume of combined solids. Now, going with this one, when you have a diagram like this one, now, here we have two solids. We have two figures. We have a cube or a cuboid and a cylinder. Now, let's say this is 35 centimeter. This one is 40 centimeter. And this one here is 22 centimeter. The radius of the circle of the cylinder is 5.6 centimeter. Now, how do you get the volume of this figure? Here we say volume of the cuboid take away volume of the cylindrical hole. Now, volume of the cuboid take away volume of the cylindrical hole gets us the volume left. Now, how do we get the volume of the cuboid? Volume of a cuboid is base area times height. Now, the base area we as length, width, height. This length by width is the base area. So that's length by width by height. Length is 35, by width is 40, by height is 22. That one will give us 3,800 cubic centimeter. Then you find the volume of the cylindrical hole. Volume of the cylindrical hole, which is we have the circle here as its base area. This is the general formula. When we say base area times height, this is a general formula which guides you to find the volume of any figure given. Now when you come to the circle, the base area of a circle is base area of a cylinder is a circle. Now a circle is pi r square, then by height. Then here the height, which is from here to here, is 40 because it's this one here to here. It is the one which is running from here to here. It is also the same as this one to here. So it is times height. So pi is 22/7 by radius. Our radius is 5.6. So we will make 5.6 as a fraction, then it will be 56/10 times 56/10 times height, whereas we have said our height is 40. That one will give us 3942.4 cubic centimeter. Now you have the volume of a cuboid and volume of the cylindrical hole. What do? We want to find the volume left. Why am I saying the volume left? This was a solid like this way. Then what did they do? They decided to drill a hole. So you find the volume of everything, assuming the hole is not there. Then you find the volume of the hole, then you take away. So we have volume left. Volume left is volume of the cuboid, take away volume of the cylindrical hole. That is 30,800 cubic centimeter, take away 30,942.4 cubic centimeter will give us 7.6 cubic centimeter. Then now you have the volume of the solid left. I'll take you through another one which is almost like this one, so that we do comparison of the two. They are almost the same. Or this one, let me this way, this way, this way, this way, this way. Now we let's handle another one which is almost the same like that. Now this is the cylinder which has been drilled, and it has a diameter of 14 centimeter. It has 34 centimeter. The width is 15 centimeter and height is 34 centimeter. Now you have been asked to find the volume of the figure. Now it's your responsibility as a learner to know that this was a whole solid cuboid, and they drill the hole. And which hole is this? The hole is a cylinder. So just the way we handled this one, the same way we say volume of cuboid take away volume of cylindrical hole. So I'm saying cylindrical hole because it is what has been removed here. So you have to be careful and know which one has been removed. So here, let's start with the volume of the cuboid. Volume of a cuboid, we said base area times height. Base area is length by height. So 34 by 15, sorry, base area is length times width. Length times width, 34 by 15, then by height, which is 34. That gives us 17,340 cubic centimeter. Then you come to the volume of the cylinder. Now, what should come to your mind first is the formula. Formula is very important, as the way we said volume is base area times height. This is a general formula. Now volume there, base area, its base is a circle. Now pi r square by height. Now pi is 22/7 because that's what you are advised to use. Then radius, this 14 is diameter. That's another thing which you as a learner you need to know. You read the question. There are two things you will be advised on pi. If you are told to use pi as 22/7, make sure you use pi as 22/7. Then now you can also write radius there so that you know that your radius is 7. These are very important elements which you must consider, because you miss, especially radius, you miss yourself. Now radius here is 7 by 7, then times height. Now the height is now this one, because this one it was lying and this one is standing. So because this one is standing, now the height is 34. With this is the same as this, the same as this one. So by 34, that gives us 5,236 cubic centimeter. Now we go to volume left. Volume left, you take volume of the whole figure, which is a cuboid, take away volume of the cylindrical hole, which is 17,340 cubic centimeter, take away 5,236 cubic centimeter, gives you 12,104 cubic centimeter. Now you have what is left. Now before we go to the next figure, you as a learner, it's your responsibility to identify the figures which has been given and the formula which you will use to solve the figures. Then you must know, am I supposed to take away or I'm supposed to add? Here you have to be careful. Like these ones, the holes were driven out. Now I want to take you to another one, whereas the holes, it was not removed, but whereas you need to add, it's a loaf of bread. Yes. a loaf of bread. Now for the loaf of bread, it looks like this one. I draw it like this, then this way, take this one, this way, takes that shape, then this way takes this shape. Now when you check a loaf of bread, it takes this kind of a shape, and sometimes learners get stuck how they are going to solve this one. So for this one, you must know there are two figures, the lower one and the upper one. The lower one, we have a cuboid. The upper one, we have a half a cylinder. So for this one, we won't take away, but we will add, because this one has been added to this one. Now if we take this loaf of bread, whereas here is 20 centimeter, this one is 30 centimeter, and this one here is 14 centimeter. Now how do I get the volume of such a figure? Volume of such a figure, the first thing you do, find the volume of the lower figure, which is a cuboid. How do I get volume of a cuboid? Volume of a cuboid is length times width times height. Then volume of half a cylinder, taking it from a cylinder, volume of a cylinder is pi r squared times h. Now half a cylinder is half pi r squared h. Now of this volume of the cuboid plus volume of half a cylinder. Let's start with the volume of a cuboid. Volume is base area times height. Now base area length is this one, width is this, and height is this. Now height is the 14, because this is 14, this also 14. Now volume is 20 by 30 by 14. That will gives us a figure like 8400 cubic centimeter. Then we find volume of a half a cylinder. We said volume is base area times height. I know most of you are wondering why I keep on repeating the formula. Formula is very important. The more you write it, it sticks into your mind. Now volume of half a cylinder here, or if you check the base of a half a cylinder, it is half a circle, so half pi r square, then times height, whereas it is a half times 22/7 times, now you come to radius here. Now this is now where I want you to be careful, because for this question they were advised to use pi as 3.14. Now always indicate those elements somewhere. Pi as 3.14, then radius. If you check here, the radius of this one is from here to here, which is the same as here to here. So diameter is 20, radius is 10. Now there, as a learner, you have to be careful, because most learners mess, not because they don't know, but because they were not keen. They didn't pick the right element or to replace the right letter. Now pi to be 3.14 by radius, which is 10 times 10, Then what is our height? Our height is here to here, which is the same as here to here. That gives us 30. Now we have our volume as 4,710 cubic centimeter. Now this is our volume for the lower figure, which is the cuboid. Volume for the figure, upper figure, which is half a cylinder. Now what's the total volume? We said we add, because this one has been added on top of this one. So we say total volume is 8,400 plus 4,710 gives us 13,110 cubic centimeter. I want to throw another challenge. It's almost the same as this one, but now that one has been drilled. Yes. It's almost the same. We just want to do it the same way. So same, almost the same thing, using the same measurements. Using the same measurements, there we had 14. Now look at this one. If you look at this figure and this figure, we are going to use the same kind of approach and method, but now only one thing, this plus. This one was added, but this one has been removed. So as a learner, you have to be very careful. Now for this one, we call it a loaf of bread, and this one sometimes we call it trough. So you have to be careful. Calculation is the same. If you mess here, you fail. So for this one, we say volume of the cuboid, take away volume of half cylindrical hole. I'll call it half cylindrical hole because it was drilled from the solid, which was a cuboid. It is going with the same approach. We said volume is base area times height. Our base area here, we have length times width times height. Base area, length by height, length by width. Now that is length times width times height. Length is 20, width is 30, height is 14. Because this is the same as this and the same as this one is 14. That will give us the same figure here, which is 8,400 cubic centimeter. Then let's go to half a cylindrical hole. Volume is base area times height. The general formula, then base area here is this one. This is the base area. It is half a circle. So area of a circle is half pi r square, then times height, which is 30. Then now we say half times 22 over 7. Our radius, just the way I told you, or pi and radius. Pi and radius, you have to be careful when given pi as 3.14, use pi as 3.14. radius here now you have to be careful, from here to here is 10, so our diameter is 10, radius is 7. Now times 22 over 7 times 7, times 10. Okay, let's say 3.14 times 10 times 10 times 30. That gives us the same figure, 4,710 cubic centimeter. Now, as a learner, you have to be accurate and fast. Here we added, what about this one? We take away. So, volume left is 8,400, take away 4,710. That will give us 3. Now, cubic centimeter. That was just a challenge for you as a learner to know that this is a combined solid and this is also a combined solid. When we talk of a combined solid, we drill the hole, it is still combined solid because we have two figures here. We have cuboid and a half a cylinder removed. It is still combined. This one is still combined also. We have a cuboid and half a cylinder added on top of that. So, as a learner, you have to be very careful when handling such kind of work. I want to take you through another one. This one now will be about trapezium, a solid of a trapezium or prism. So we can clear with this one. And as a learner, what is important when you are working out question concerning volume, base area is the most important thing. Base area, the most important thing. Now, let's come to this one here. This is this one is trapezium. If you check that one, it's trapezium. So for this one, here is 8 centimeter. This one is 6 centimeter. This one is 9 centimeter. 9 centimeter is this one here. Then this part is 5 centimeter. Now for this figure, its base area is this one. This is what we use as base area. Then now when talking about volume, which is base area times height, now this time we are going to take the height to be this one and this one. Most learners get confused when it comes to identifying the height when finding volume. When you check this figure here, sometimes you may be asked which one is the base area. Base area is this one here. And now these ones will be the height. Now when we come to this one, when the base area is trapezium, now you see these lines running or moving away from the base area. Those ones are the height. And the angle at which they leave the base area is 90 degrees. So this will be its height, or this one, or this one. Now what do we do? When you come to base area, we find area of trapezium. Area of trapezium is equal to h over 2 into a plus b. Now you deal with this one first. And now for the trapezium, its A is this one, its B is this one, and its H is this one. So we say H over trapezium is 6 over 2 into A and B. A and B are the two parallel lines. There are two parallel lines, this one and this one. One is small and one is big. So A is 8 plus B is 5. This one is the same as this one, so B is 5. Its B is 5. Then now area here divided by this is 3 into 13. That gives us 39 square centimeter. Now when you come to volume, volume is base area times height. And we said height, now we take this one, which is 9 times 9 centimeter. Now, what is the volume? Volume is 39 times 9, which gives us 351 cubic centimeter. I hope as a learner, up to that point, you are somewhere. And just as we said, you have to consider this first. And you can see how I've brought the base area this side. And I solved it so that this height of a trapezium should not confuse you with the height of the volume of the whole figure. Moving to the next figure, we have this one here. Now we are going to do a wedge, whereas half a cylinder has been railed. Wedge is also called triangular base prism. Triangular base prism. Triangular base prism is also called a wedge. Now we have this figure, this one here, this one here. Then we have this one, this way, this one here. Now here is 90. So if this is 8 centimeter, this is 8 centimeter, then let's remove this one because without this is already complete. It's already a wedge. Now this is 12 centimeter, and this one here to here is 5.6 centimeter. Now looking at this figure, you have been asked to find the volume of the figure below. Use pi as 22/7. For this figure, if you look at it, for a learner, it looks complicated. But when you break it into workable figures, it becomes very easy. Now the first thing you have to ask yourself as a learner, one, I have a wedge. Wedge, triangular, base, prism. Then now you take away volume of half a cylinder. Now let's start with the wedge. You realize most learners are conversant finding volume of half a cylinder or volume of a cylinder. but when it comes to a wedge, it's a mountain to most learners. Now, when you find it hard to work out the figure, pick the general formula, which we say, now we start with the wedge, where we say volume is base area times height. From there, you have started breaking it into simple workable figure. Now, what do? You ask yourself, this wedge, which one is its base area? Base area is this one. Now, this is the base area of the wedge. Then you ask yourself, this base area is which shape? It is a triangle. So, how do I get the area of a triangle? Area of a triangle is half base times height. So, that's now the base area, which is this one. Now, base area is a half times base. Base is this one. Base and height make right angle. So you check the two sides which make right angle, like this one. It is 8 times 8. That one already half times base times height. That one has already given you the base area. Then now times height. The reason why I've decided to circle this one, so that you don't confuse the height of the base area and height or length of the figure. So go do it one by one. That's why we have even drawn this one, so that you can see that we are dealing with a triangle. So a triangle is half times base times height. Then by 12 for this one. That one will give us this one here, 1, here 4. That is 32 by 12, which gives us 384 cubic centimeter. Up to that point, you have the volume of a wedge, which was looking complicated, but you can see from the calculation it's very simple. Now find the volume of half a cylinder. We said base area times height, and its base area is half a circle, so half pi r square times h. So half times 22 over 7 times radius. Remember, 5.6 is diameter. Diameter is 5.6. So radius is 2.8. Now we'll say 28 over 10 times 28 over 10. Now r square, r times r. Then times height, which is, height is still the same, this one and this one, which is times 12. That gives us 147.84 cubic centimeter. Now you have the volume of the wedge and volume of half a cylinder. Now you take away. That's now where you have to be very careful taking away. Now volume left. Volume left is 384.00. Take away 147.84. That gives us 6. That gives us 1, 6, 3, and 2 cubic centimeter. Okay. Now, I don't think you will get any other complicated figure which will be hard to work out, so long as you are able to identify the kind of the figure and the name of the figure and its formula. Formula is very, very important. Formula is very important. As we go to the next one, let me answer some questions from some learners. Okay, now there is Joy asking. Here I'm Joy. Excuse me, teacher, on the bread-like figure, why did we use 30 as the height and the height was 14? Let's go back to bread-like. The person is saying height is 14. I'll quickly take you through it so that we see where the confusion might be. So as a learner, please be very careful. So bread-like was like this way, this way, this way, and this one here, like that. So 20 centimeter, 30 centimeter, 14 centimeter. Now this is length, this is width, and this is height. That one, length times width times height. When we say length times width times height, we are dealing with a cuboid. Cuboid. We are dealing with a cuboid. So then it's now length times width times height. Height. Now the height you are talking about is when you are talking about the cuboid. Volume is length times width times height, which is 20 times 30 times 14. That is now cuboid. I'm talking about cuboid. Now when you come to volume of a half a cylinder, look at this half a cylinder. This is half a cylinder. It looks like this way. This way. Now when you look at this half a cylinder, this is diameter and this is radius and radius. Now its height is this one. And where does it take its height? Is this one. This is 30 and this is 30. So that's now this is 30 and this is 30. Now when you come to half a cylinder, its height is 30. But when you come to a cuboid, this is length times width, height, height, height. That's why we said they are combined solids. And for combined solid, you realize each takes its height, depending how the figure which has been added is appearing. For example, if now you have a figure like this way. Now, if you have a figure like this one, and now the cylinder which has been removed is standing, you can't still take 30. That time now its height will be 14. So you must check the figure removed or the figure added, how it is. It is standing upright or lying. If the figure is lying, now you know the height will be this one. If the figure is standing, you know the height will be this one. So that learner who is asking, why did we take height of half a cylinder to be 30, not 14? Remember, half a cylinder was lying. It was not standing. So because it was lying, we take 30 as its height. But that 30 is not height of a what? Of a cuboid. So after finding the volume of a cuboid, find volume of half a cylinder, which we say a half times pi r, which is 10, then height is 30. I know this is where you are getting confused. Height of a cylinder, of that half a cylinder, is this one. Remember, for the cuboid, it is width. So you break them one by one. You solve the lower one, you get your answer. You solve the upper one, you get your answer. Because this was added, you add it. You add the two. Yes. Or going with another question. Or repeat the formula of combined trapezium. Formula of combined trapezium. Combined trapezium, combined trapezium, this is the trapezium. Now, this is the trapezium, and that will work as the base area. So, yes, base area, cross-sectional area. It is the same thing. Cross-sectional area is the base area, for your understanding. Now, what do? We said for the trapezium, here is 8 centimeter, here is 6 centimeter, and here is 5 centimeter, here is 10 centimeter. Now, you deal with base area first. Then now, where is the height of the figure? We'll take these ones, these ones, these ones. Here was 9, not 10. Here was 9. Now, we say volume is base area times height. One by one, base area is trapezium. Area of trapezium is equal to h over 2 into a plus b. Now, h over 2 into h is 6 here. Now, we are dealing with the trapezium. When you are dealing with trapezium alone, focus where the trapezium is. Now, height is 6 over 2 times into bracket a plus b. A is 8 and b is 5 because this 5 is the same as this one. So, plus 5, which we said this is 3 into 13 gave us 39 cubic square centimeter. Then now, that's the base area. It is what you put here as your base area times height. Now, which is the height? You see, this is the base area. Now, if this is the base area, this is the height, or this one, or this one. I hope for the trapezium, that learner, you are now okay. Coming to this one. She's asking, calculate the second one, number 2. Okay. Yes, number 2 on the diagram sent, it's this one. Number 2 on the diagram you have sent, it looks like this way. It's a cylinder. With the cylinder, they decided to drill a square like that. Now, if you check here, we are told it is 28 centimeter. Then here, this what was drilled, the cuboid which was drilled as a top of 6 by 6 centimeter. Then the height of the cylinder is 25 centimeter. Now, for the learner, remember the height of what was drilled is also 25 centimeter because it is standing upright, and if it is lying, it will take the height, which is the diameter. So for this one, the height is 25. What do I do? Find volume of a cylinder, take away volume of a square, volume of a cuboid hole. Now, as a learner, what do? You'd go one by one. So we say volume of a cylinder is base area times height, whereas base area here we say 22 over 7, 22 over 7 because it's a circle, times 14 times 14 times height, which is 25. So which is pi r squared h. That will give us 15,400 cubic centimeter. Now you move to the inner one. Now a cuboid, we said volume of a cuboid is length times width times height. Now 6 by 6 by 25. 6 by 6 by 25. 6 by 6 by 25 gives us 900 cubic centimeter. Now, what is the volume left? This was removed. Now, it is 5400. Take away 900. That will give you 14,500 cubic centimeter. I hope you are satisfied with that. Joseph Lisan, can you help me with the formula of pyramid? With the pyramid, as a primary learner student, we are not finding the volume of a pyramid. And when you talk of a pyramid, we don't know the kind of pyramid you are talking about, because we have square-based pyramid, we have a triangular-based pyramid, we have a rectangular-based pyramid. So as a learner, I'm not sure the kind of pyramid you are talking about. For the pyramids, the only thing you are supposed to know about them, the number of faces, the number of edges, and the number of vertices. Not the volume, not the area. That's you as a learner in primary school. Hey teacher, can they ask for a height of a trapezium? Yes, height of a trapezium can be asked when you are given area of a trapezium. They can ask you height of a trapezium. Hey mwalimu, I am Gabriel. In case of hemisphere, how can we take it? Kindly, hemisphere also I'll take you to that high school, not primary. Lastly, I will only help this learner who has said, hey teacher, can they ask for a height of a trapezium? That one we are going to do very fast. If you are asked the height of a trapezium, if you are asked to find the height of a trapezium, as a learner, what do you do? For example, if I am given this trapezium, then you are told here is 6 centimeter, here is 8 centimeter, so height is not given. Then you are given here as 5. Area, you are given as 39. What do? You say area is equal to h over 2 into a plus b. Now, h is not there. What do? I just write h over 2 into a plus b, 8 plus 5. Then that is the area which have been given as 39. Now, as a learner, what do? I say h over 2 times this one, which is 13, is equal to 39. Then h times 13 is 13 h over 2, which is 39. Then now, this one, you take the other side as reciprocal, which means now you are left with height is 39 times 2 over 13. 13 here 1, 13 here 3. Height is equal to 6. Now use the formula. Use the formula to get what is missing. So long as you have the formula, now you replace the figures which are there with what is there, and now you are left with height. Now this is now like an algebraic expression. Thank you, learners. Thank you, listeners, for being keen. I'm happy with the questions you have just asked. Have a nice day. See you next time.